Welcome. Let's understand the idea of eccentricity in a parabola. Well, eccentricity, it is a value that we use to classify conic sections depending on its curvature. We're going to use the letter of E to represent eccentricity. And the way that we define this value is by a ratio of distance. On the numerator, it is the distance that the point in the conic section has to the focus. And on the denominator, it is the distance that any point has to the directrix. The distance is any point in the graph. And sometimes this ratio, we just write it as capital D subscript F to represent the distance to the focus, and capital D subscript D to represent the distance to the directrix. So let's visualize this before we think about the value of the eccentricity of a parabola. So let me just sketch a random parabola. And let's say that the focus is here, and let's say the directrix is somewhere down here. Well, remember that we define a parabola as a collection of points that are equidistant to the focus and directrix. So if we choose any point in this graph and we measure the distance that it has to the focus, it should be the same as the one that it has to the directrix. And you can see here that this parabola is not down to a sketch, but those two distances should be equal. And the same if we would have chosen any other point. The distance to the focus, it is equal to the distance to the directrix. Well, if by definition, those two distances are equal to each other, then the numerator of our ratio, it is equal to the denominator of our ratio. And anything divided by itself, it's always 1. So we can claim that the eccentricity for any parabola is always 1. So now let's illustrate this result. Well, let's recall that we said that the eccentricity, it is defined as the ratio between the distance that any point has to the focus divided by the distance that any point has to the directrix. But let's choose any point in the parabola in the left, and let's see what's the ratio that we obtain. So how do we use this point right here? Well, notice that the distance that this point has to the focus, it is 8.5. And the distance that it has to the directrix, it is also 8.5. So the eccentricity of this parabola, it is 8.5 divided by 8.5, which is equals to 1. Now let's choose another point. Let's choose this point right here. But the distance that this point has to the focus is 5.91. And the distance that this point has to the directrix, it's 5.91 as well. So we can say that the eccentricity is 5.91 divided by 5.91, which is also equivalent to 1. So regardless of any point that we choose in this parabola, let's choose this one here now, we will obtain the same result. The distance that it has to the focus is 10.77. The eccentricity is 10.77 divided by the distance that it has to the directrix, which is 10.77 as well, which we still have the value of 1. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.